We're going. So to save some time, I'm gonna try to describe what I think the mission is, and tell me how far off I am, and you can
Okay.
correct me, and then we'll go from there. To my knowledge, the double asteroid redirection test mission, the DART mission, is we are in the next like 12 to 24 hours. We're shooting a spacecraft into space that will, in 11 months, about September of 2022, hit a small moonlet that is going around an asteroid. And what we are hoping to do is to hit the moonlet in a way that throws off the orbit of the asteroid, kind of like a big cosmic billiard shot, to move the asteroid without actually hitting the big one, but hitting the smaller one rather. How far off am I?
I mean, you're pretty close. You have a lot of the parts right. Yeah. So we're gonna launch. Hopefully, the window opens tonight Pacific time, and so we're going to launch our spacecraft at DART towards the Didymos Dimorphos system. And so that's the bigger one and the smaller moonlet. And so what we're hoping to do, what we're planning to do, is to impact directly into Dimorphos so that we change the orbit of Dimorphos around Didymos itself. And so we're primarily concerned with the orbit of Dimorphos, which is something that we can observe really easily from the ground using telescopes. And so that's one of the really interesting things about this target. We can understand that orbit right now, we can impact it and change that orbit, and then observe it again after we do that and understand what that orbit is again later.
You say you're concerned, or should we be concerned about Didymos and Dimorphos?
No, absolutely
Oh,
not.
okay.
Didymos and Dimorphos, they're a part of a binary system, and they are near Earth objects. So they're in the space near the Earth, but they aren't actually a threat to the planet.
How
And so
far out are these guys?
how far out are these guys? Well, they change a lot. It actually has what we call an eccentric orbit, so it
Oh
can go
yeah.
out beyond Mars, but it can come in, and around the time of impact, it'll be something like shoot, that's a good question. I used to know the answer to this question, but like I know it in astronomical units, which is not very helpful.
Okay.
Um, but it's going to be actually really, really close to the planet, which is going to be very exciting. It hasn't been this close to the planet since 2003, and won't be this close again until the 2060s. And so that gives us a really great opportunity to be able to talk to the spacecraft, but also to observe it from the ground.
Got it. So a lot of the literature on this mission is kind of defensive. It's like, hey, we don't really know like what we're trying to do. It seems like you guys are just trying to learn. What is the overall purpose of this mission?
I think that's a really good way to put it. We are trying to learn. Planetary defense is relatively new as a field, and there's really two sides to it. There's the discovery side, where we try to discover as many of these near-Earth objects as possible, and there's the mitigation side, the reducing the risk side of it, and that's where DART falls in. What would we do if something was going to impact the planet? Right now we have some ideas, but we haven't actually tested any of those, and so that's really what the DART mission is set out to do. We're going to test this idea of a kinetic impactor, which is essentially taking our spacecraft and crashing it into Dimorphos to see how we change it.
Yeah, no, I'm drawn to the idea just because it sounds great. It just sounds, we're gonna crash a thing into an asteroid. I don't think people are gonna have a problem with that. It just sounds fun. And the idea that we can learn from stuff like this. I host a show called 2100 that it's a futurist podcast, so it thinks from the perspective of what will the world be like in 2100. So what do you think what types of things are we expecting to learn from this, and how could it benefit in the future?
Well, I mean, we're going to learn a lot about just the experiment itself. We know how much the spacecraft will weigh, essentially, and we know how fast it will be going. What's going to happen to the object that it hits? In some respects, it's a very basic physics experiment that we still don't know the answer to, because we don't know what this asteroid is going to be like. Asteroids so far that we visited have been wildly different from each other. Some of them are really, really hard. Some of them are really squishy. What happens when you take that spacecraft and you ram it into something else? And so there's a lot to learn, both from a scientific scientific perspective about asteroids in general, but also in how would you take that information and apply it to this specific problem of potentially needing to save the planet one day.
Is this the first time we've ever intentionally crashed into a space object?
As the primary mission?
Yes,
Yeah,
intentionally.
yeah. Well, we've certainly had things where we've done different kinds of landings at the very, very end of the missions when everything else is totally done. And those aren't nearly as dramatic a crashes here. But like, this is the first time that this is the primary purpose of this spacecraft, is to crash into this asteroid.
That's historic, and that's what I try to focus on. I've never heard of anything like this, and I'm excited to be getting the word out about something like this. Is there any chance that the mission that we hit the asteroid in a bad direction? Has that risk been minimized?
Well, because we're going to hit the moon of the system, Dimorphos, instead of the primary object, we're changing the orbit of the moon around Didymos. We're not changing the orbit of Didymos around the sun. And so there's really no possible way that we can knock the moon loose or change the orbit of Didymos substantially. And so there is no threat here.
Okay, no. Well, that is the majority of my questions that are directly related to DART. Other questions, just in general for you. How did you get involved with NASA? That's the golden ticket. That's the thing. Everyone talks about wanting to be an astronaut. Everyone wants to talk about NASA, space. Space is back in a big way. It seems like there was like a 30-year gap of time where we weren't doing so much space stuff. So could you give a little insight into your journey into space and the space field?
Yeah, I mean, I did some work after I graduated at NASA Goddard Space Flight Center, and so I was there in what's called a postdoctoral position. And so I was there to learn from people, and I was able to gather a lot of collaborations, including working on this mission, which is headquartered primarily at the Applied Physics Laboratory, which is really fairly close to Goddard. And so that's how I got involved in the mission. Right now, I'm an assistant professor at Northern Arizona University, but I was able to keep up those collaborations. And I've been working in this position as the lead of the observations working group, which is, we're primarily responsible for these observations of the moon going around the primary asteroid, which is really exciting. And so I kind of stumbled into it in a way because most people that end up on these spacecraft missions are engineers or people who think about things from a different perspective. But I use ground-based telescopes all the time. That's what I do. That's what I've been trained on, and that's what I am particularly good at. And so this is the first mission that's ever come my way where that is such a critical component to the entire mission overall. And so it's been really exciting to kind of make that transition into the NASA spacecraft realm as, myself.
No, it's nice to have a thing that you are like so dedicated to and like good at, and then that's what's needed. And then you just hit the hole, you fill the role. When did this start? When did you start working on the DART mission?
We've been playing around with this idea for a really long time. The first time that I can remember going to meetings was probably at least in 2014. And, we were thinking about it very clearly, like, how do we get this to go? And one of the things that we started was actually observing the moon to see if we could start to understand the orbit, because it was discovered in 2003. And then nobody observed the orbit until we started doing that in 2015. So there's this huge gap. And so we figured that if we were ever going to make this possible, we had to understand what the moon was doing to begin with. So that's really when we started this observing effort. And, it's kind of grown and grown from there. And, I just keep thinking that, when we started, we were really just hoping that this would work. And when they told us, that it was selected and we were going to fly, we were all, just kind of like minds blown, really excited about this. And now we're here today. And it's really, really exciting to have watched the entire progression.
So the launch window opens when?
It opens tonight at 10:21 Pacific time.
10:21 Pacific time, PM?
Yes.
And then when does it close?
Well, we have various launch windows every day, but the launch window itself doesn't actually close until February.
Oh, okay. So how soon could we see this spacecraft go up?
Tonight?
Oh,
as soon as tonight.
all
Yeah,
right.
which, fingers crossed it does.
Well, we'll be keeping an eye on that, and then it wouldn't for 11 months. Then we'd hit the target from launch.
Yes, yes. So assuming that it goes up soon, it will be in late September of 2022.
Okay, and my final question for you is a little vague, but it's something that I always ask people in reference to the 2100 question,
Mhm.
like about where technology will be. And I'd have to. You're from NASA. I have to ask you this. What do you see as the future of space travel in the year 2100?
Oh, I mean, that's a hard question. When I was younger, I know people had all this very futuristic visions of what we thought was going to happen. Flying cars and all these things. But now I actually see commercial space coming in and making it possible for people to do it. It's certainly not to the level of you and I right now, but I'm really hoping that in the future normal people can actually go to space if they choose to. I don't know that we're going, to colonize the solar system like so many science fiction books, but I think we can at least go there and see what that's like.
No,
Um,
as someone who's this is kind of my focus, the 2100 thing, because I'm 4 seasons deep on a podcast about it, and I've talked
mm,
to people from all walks of life. Flying cars is the first thing mentioned, and it's impossible. The engines would fall on people. People would litter out of it and kill you. You'd kill people. All
yeah,
people would be
basically.
dying at a crazy rate, but only like intergalactic cars, maybe.
Yeah.
Do you have anything that you'd like to say to the people of the year 2100, or any thoughts for the people of the future who will be listening to this? Because these interviews will be saved for them in the future to listen back to.
I mean, that's a really good question. I mean, I hope all the people in the future will see this as a resounding success because, we're really excited about the potential here. And also really just like opening up this entire field of planetary defense, because right now I feel like it's mostly something it's kind of joked about in disaster movies and things like that. But, we can actually solve this as a natural hazard by discovering more objects and then by coming up with ways to reduce the risk of those objects should we find anything that was hazardous. And so I think that this is really the beginning of a huge growth in planetary defense.
Well, I just want to say thank you so much, Dr. Christina Thompson,
Um,
um, for coming and doing this with me. I know that you probably have a busy day packed with interviews and then a stressful day of watching a rocket launch, and I appreciate getting that you talked to me today.
well, thank you so much for talking with me.
Now, have a good day.
Bye.
Gotta stop the recording.